Mercury kept arriving in the wrong place. Not by much. The difference was tiny, but every time astronomers tracked the planet, ran the calculations, and compared prediction against observation, a small gap remained. The response was not panic, it was recalculation. Every correction was supposed to make the discrepancy disappear. Instead, the discrepancy survived the correction. Mercury continued moving around the Sun, and the numbers continued refusing to line up perfectly. That created a strange image. On paper, the orbit followed one path. In the sky, the planet traced another. The mismatch was small enough to overlook once, but not small enough to disappear. The problem grew because the system doing the predicting was supposed to be reliable. The planets moved. The math worked. The predictions matched reality. Except here, Mercury was not behaving wildly. It was behaving almost correctly, which made the failure harder to dismiss. A proven system had produced the wrong answer for a real planet. And if a trusted calculation could contain an unexplained error, the concern was no longer Mercury itself. The concern was what had slipped into the math without anyone noticing. Astronomers did not abandon the math. They tried to save it. If Mercury was arriving where it should not, then something unseen might be pulling on it. Somewhere inside Mercury's orbit, hidden in the glare of the Sun, there could be another planet. So the search began. Observatories tracked the sky. Calculations were refined. Known planetary influences were recalculated again and again. The suspected world was not treated as a rumor. It was given a name: Vulcan. For a time, that answer felt solid. An unseen planet was easier to accept than a flaw in a system that had already proven itself across the solar system. But the problem refused to cooperate. New observations arrived. The orbital discrepancy remained. More calculations followed. The discrepancy remained. Searches continued. Vulcan failed to appear. Each attempt removed another place for the error to hide. The explanation grew more specific, while the evidence supporting it grew weaker. The situation began to reverse. At first, Mercury was the problem, and Vulcan was the solution. Now, Mercury was still producing the same mismatch, but the solution itself was becoming difficult to defend. The anomaly survived every correction. What had looked like a measurement issue was slowly turning into something more dangerous. The observations were no longer under suspicion. The explanation was, the anomaly was still there. But there was a reason not to panic. Every day, the same mathematical system continued doing its job. Planetary motions could be predicted. Eclipses arrived when expected. Calculations made long before an event still matched what eventually appeared in the sky. The machinery of prediction kept working. If the same equations could still predict eclipses, planets, and future events years in advance, abandoning them felt reckless. That created a powerful contrast. Mercury carried a small mismatch that refused to disappear. Yet everywhere else, the larger system continued producing correct answers. The more successes accumulated, the harder it became to believe the entire framework was broken. A single crack in a wall is concerning. A wall that remains standing through every storm is harder to abandon. So attention drifted back toward Mercury. Maybe the problem was local. Maybe some special condition existed near the Sun. Maybe an overlooked detail was still waiting to be found. Those possibilities felt far more reasonable than discarding a system that continued proving itself again and again. The anomaly survived. But so did Newton's success. That balance created a period of uneasy confidence. The discrepancy looked real, yet small enough to isolate. The theory looked reliable enough to preserve. For the moment, Mercury seemed less like evidence of a deeper failure and more like an exception that simply had not been explained yet. The only problem was that the same exception kept returning. Then the situation changed. Not because Mercury changed, not because Vulcan was finally discovered, not because a new correction had been added to the old calculations. The change came from a different direction. In 1915, Albert Einstein applied general relativity to Mercury's orbit and followed the planet through a new set of equations. The result produced something no search for Vulcan had ever delivered. The missing motion appeared. The unexplained excess that had survived decades of observation and calculation was no longer missing at all. When Mercury completed its path around the Sun, the prediction now arrived at the same place as the observation. Nothing extra had to be inserted into the solar system. No hidden planet was required. The discrepancy simply vanished. The same observations remained. The same Mercury remained. Only the explanation had changed. And suddenly, the numbers fit. That outcome carried a consequence far larger than Mercury itself. For years, the anomaly had been treated as a problem waiting to fit inside an otherwise successful framework. The assumption was that the theory was secure and the explanation was missing. Now, the explanation had arrived without preserving that assumption. The surviving observations had not been wrong. Mercury had not been wrong. The missing planet had been wrong. And once that happened, the burden shifted. The failure no longer belonged to a difficult planet orbiting close to the Sun. It belonged to the limits of the older theory that had been protecting itself from the anomaly. Mercury was never breaking the math. Mercury was marking the boundary where the math stopped working. And if gravity behaved differently than Newton had believed, the question was no longer why Mercury was unusual. The question was what else had been misunderstood. The mystery ended with a number so small that most people would never notice it. A slight mismatch in Mercury's orbit survived every correction, every search, and every attempt to explain it away. Yet that tiny error carried an unexpected consequence. It became one of the first real-world confirmations of general relativity. The effect was subtle. Mercury still followed its familiar path around the Sun. The planet did not suddenly move differently. The observations did not change. What changed was the understanding behind them. For generations, gravity had been treated as a system that seemed complete. Its predictions worked so well that success itself became evidence of certainty. Mercury exposed a limit hidden inside that success. The older theory remained useful. It could still predict enormous amounts of the physical world with remarkable accuracy. But it was no longer the final description of how gravity behaved. The planet had never been rebelling against the laws of nature. The laws being used to describe nature were incomplete. That is why the numbers never fit. Not because Mercury was unusual, not because the observations were wrong, but because reality itself was operating under rules that the older mathematics could only approximate. A planet nobody considered dangerous had done something far more important. It had exposed a flaw in one of humanity's most trusted ideas. The numbers never fit because Mercury was showing the truth long before anyone understood what it was seeing.
Only humanity's trusted explanation disappeared.